Yes, learners, hope you're okay. We are going to continue from where we stopped in our last lesson. To give a brief recap, we looked at structures of materials that easily break or easily shatter, and those included glass, ceramics, and then concrete. Now we want also to look at the other side of the coin about the structures of materials that easily break, and these include the plastics and fiber. We are going to begin with the plastics. Plastics, for example, polyurethane, nylon, and then melamine. And each of those plastics is going to be discussed in details. Yes, plastics are man-made, therefore referred to as synthetic materials. Look around your kitchen room, your sitting room, bedroom, and identify some examples of plastics. Having done that, let's also look at the types of plastics. There are two types of plastics. One are the thermosoftening plastics, also known as the thermoplastics. These ones, when they are heated, they can be molded into different shapes. For example, polyurethane. And why is it possible to mold the polyurethane into something else? It's because the polymer molecules in polyurethane are attracted to each other by weak intermolecular forces of attraction, which easily break. Then we also have the thermosetting plastics. These are molded once but cannot be softened by heating. You can take an example of the melamine, for example, melamine plates or cups. You find that you can put hot tea in a melamine cup, but it will not change. Hot food on a melamine plate, but it will not change. Then electric cables, they are also not affected by heat. Then bakelite. An example of bakelite are the bakelite sockets. You find that if you hit them, they will simply crack, but then they will not be reshaped. So below are some of the examples that I've been able to put down in diagrams, like the sockets, the plates, cups, the spoons, the electric cables. All those are examples of plastics that do not change their shape when they are heated. Properties of plastics. As we have seen before when we are looking at properties of glass, properties of ceramics, properties of concrete, we also look at properties of glass. And one of them is that plastics are non-reactive. That's why we are really fighting hard to get rid of these plastic bottles. Once we retain them in the garden, you find that they become a burden to our soils. Then plastics are strong, durable, and flexible. I can be able to store something in the plastic bottle and get it at any time I want. Plastic is an insulator. We've seen some of the saucepans that have handles which are made of plastic, so they will not conduct heat. Some plastics get deformed on heating. For example, if you get a plastic bottle, put it on fire, it will get deformed. Then some plastics are flame resistant and can tolerate heat. Melamine, put hot tea in a cup of melamine, it will not change, and you can use it for quite some good time. So structure of plastics. What is the structure of plastics? You find that the structure of plastics is mainly made up of carbon atoms, which are joined together in long chains called polymers. Poly means many. So what are polymers? Polymers are compounds that are made by many small molecules joined together to form a large molecule. I can give an example of polyurethane. The monomer for polyurethane is ethene, as I have illustrated here, and ethene has a double bond in between. There is a carbon atom and another carbon atom here. And then each carbon atom is attached to two hydrogen atoms, as you can see here. So ethene is given this name ethene because of the double bond between the carbon atoms. But when many ethene monomers join together, they form polyethane. For example, when you look at this polymer of polyethane, how many monomers of ethane do we have? We actually have 4 monomers of ethane. And when these monomers are joining together, then the double bond breaks and we remain with only a single bond. So you can see that when you count how many ethane monomers that we have, there are actually 4 ethane monomers which have combined together to form a polymer of polyethane. Not forgetting that these carbon atoms are joined together to form a long chain, but also attached at the end are the hydrogen atoms. So it means that it is able to accommodate many monomers of ethane. That's why we leave this one open. The extreme ends are open. We don't put any other atom because another monomer of ethane can simply join here. So hope I've been able to illustrate the main word, which is poly, which means many. When many monomers join together, they are able to form a long chain polymer, and in this case it is now known as polyethane. So I've talked about a polymer and hope you've understood it. But what are the properties of polymers? What we should know is that polymers are chemically unreactive. That's why polythene, you can put their water. In the plastic bottle, you can put their water. Polymers are chemically unreactive. Then they are poor conductors of heat, and they are solids at room temperature. Then some polymers, for example the thermoset plastic, can be molded into different shapes. Then they are electrical insulators, that one I've already mentioned, and they are strong and hard, for example the wires. So what will the properties of polymers depend on? Properties of polymers will depend on the reaction conditions, that is the temperature and the pressure. Then they also depend on the monomer that has been used to produce them. The monomer is very important. So we shall see that polythene will differ from nylon, nylon will differ from another plastic, just simply because the monomers are different, and also the reaction conditions are different. I'm just repeating here the example of polythene, where the monomer is ethene with a double bond, just like the way it is here. This is the monomer, and then the polymer that has been formed is this one. Yes, this is just explaining what I've talked about, and they are joined together by a covalent bond. They are joined together by a covalent bond. So the bond between carbon and hydrogen is a covalent bond. The bond between carbon and hydrogen is a covalent bond. Most plastics are made from crude oil, coal, or natural gas. So these gases are small molecules that are made from crude oil. It takes place under high pressure and in presence of a catalyst. So when I have crude oil and I subject it to different temperatures, I'll be able to obtain different natural gases and also obtain coal, which I will use to make the different plastics that I need. However, this has to take place in presence of a catalyst. And what is a catalyst? A catalyst is a substance that speeds up a chemical reaction but remains unchanged at the end of the reaction. Then another point to note is that the strength of a polymer also depends on the electrostatic forces that hold the chains together, and these are caused by the nitrogen and the oxygen. We are going to look at the nylon, we are going to look at the melamine. You'll find that the electrostatic force that is holding them is the one that is leading to that type of polymer of a nylon or melamine. Examples of plastics include polythene, as I've already mentioned, nylon, melamine, and then polyurethane. And we are going to discuss each one of these separately. But I've already given a brief introduction of polyethylene. How is it formed? Then all I need is to go into the nylon, melamine, and then the polyurethane. So briefly, to give a brief recap, polyethylene, many monomers of ethene combine at a temperature of 200 degrees Celsius and a pressure of 2000 atmospheres to form polyethylene. This polyethylene is a branched polymer that prevents close packaging. Just like you can see here, if this is one chain, when the one chain combines with another, now we form a branched polymer. When they combine with others, then they form a cross-linked polymer. But what we have to note here is that they are branched. You cannot determine a particular pattern in which the polymer is arranged. So because of that, they do not allow cross packaging. And that's why when you have a polythene, you can easily stretch it just because the polymer molecules are not compacted together. And that gives the reason why it can be molded into different shapes. So due to the branch chains of polymers, the branches are not held closely to each other very strongly. That's why polythene is not strong. Then let's look at another polymer, that is nylon. So still nylon is a plastic which is strong and flexible. The polymer molecules contain nitrogen and oxygen atoms that are joined together by electrostatic forces, hence holding chains together. The forces make the molecules of the polymer line up in the same direction, making nylon very strong and can easily slide over one another. So the forces between the molecules are electrostatic but not chemical bonds. Therefore, they can slide over one another. That's why nylon can be stretched a lot without breaking. I want you to clearly note this. Why are you able to stretch nylon? Look at those ropes that are made out of nylon. You can stretch them. You can tie something tightly by stretching, but they don't break. The reason is that the polymer chains are held together by electrostatic forces, but not chemical bonds. Therefore, they can easily slide over one another. So this is an example of the polymer chain of nylon, and you can see this is a chain, and this is another chain, and then this is also another chain. And in between them we have oxygen, hydrogen, and then nitrogen. So the electrostatic force of attraction that is holding this chain, to this one, there is an electrostatic force of attraction, but we don't have the chemical bonds, for example, the covalent bonds holding this chain to this. That's why nylon can easily stretch without breaking. Yes, these are some materials that are made out of nylon, for example, the ropes, the threads, and then the cloths. And you can also add many others that you make out of nylon. Then that takes me also to melamine. Melamine is another example of a plastic. In melamine, there are strong covalent bonds between the polymers. That's why melamine is rigid, hard, can't be stretched, and cannot melt. So when melamine is heated, it burns without melting, but simply cracks. We need to understand this. Why is it melamine, when heated, it doesn't burn? It doesn't melt, but it simply cracks. The reason is that the molecules in melamine are held by strong covalent bonds. Therefore, that makes them rigid and hard, and they cannot melt. Still, I have a brief illustration of the atoms of oxygen and hydrogen in melamine forming the covalent bond, as you can see here. So these are some of the melamine materials: the cups, the flower vessels, the plates, the glasses, the spoons, all those are made out of melamine. Then we have another example of a plastic, that is polyurethane. The polymer molecules are loosely attached in a random way. This allows the plastic to be squashed or stretched without permanently changing their shape. And they are also strong. Polyurethane, you find that this is how the polymer chains are arranged. They are somehow interlocking, but there are no bonds that are holding them together. So that's why you can scratch them, you can stretch them, but you cannot alter their shape. So these are some of the materials that are made out of polyurethane. You can see these shoes. You can fold the sole of this shoe. You can also look at the gumboots. Look at the gloves. I can fold the gumboots, but I will not change the shape. I can fold the gloves, but I will not change the shape. I can fold the sole of this cover, but I cannot change the shape. This is a wheel. This is a chair. This is a shoe itself, having this sole made of polyurethane. And this is a steering wheel. I can change it in any direction, but then I cannot alter its shape. So, having looked at those materials that do not shatter easily, that is the nylon, the melamine, the polyurethane, the polythene, I want you to discuss some of these questions. And all those ones we mentioned are under plastics. So why is the unreactivity of plastics both useful and problematic? Yes, taking a soda, packing a soda in a plastic bottle is very important because I can freely move with it wherever I want. But then how is it also a problem to the environment? Look at it in such an aspect. Why are plastics more popular compared to metals? Why is it plastics are more popular compared to metals? Look around town, plastics are more disposed everywhere, but you can hardly meet a metal. Why? How are the properties of plastics suitable for their uses? 4. How can you control environmental pollution in Uganda using the plastics? How can you control environmental pollution in Uganda? Yes, I believe you will take off some time to answer those questions. And I believe still these questions, after you've answered them, are going to guide us into the different other materials that we have not looked at. Thank you. Have the best day.